This session brings together quite a lot of components. The aim is high level to present how this can work together. So it's not super in-depth in any specific one. Maybe first introduction. So I'm Deconinck. I'm a researcher at Howest Cyber 3 Lab. We're a University of Applied Sciences in Bruges in Belgium. We do applied science. This means that on the scale of technology readiness level, we work with technologies that are quite ready to be adopted, yet still need a little push or some research. That's the main focus we have. And our research team works on AI, cybersecurity, immersive technologies, and digital trust. We're also an associate member of Linux Foundation Decentralized Trust, or LFDT. We're hosting the LFDT Belgium meetup group. So on 4th of September, we will have one on trusted AI agents, which I can really recommend. Our team members are certified in a wide range of decentralized technologies, such as Hyperledger Fabric and Bezu. But we're not only limited to blockchain. And we're a founding member of LF Decentralized Trust, the European chapter. So if you have questions about this or want to be more involved within this group, you can also contact me. This morning there was a session here on EPSI, European Blockchain Service Infrastructure. We are a node provider, or we are hosting a node for EPSI, and we're also involved in quite a lot of projects regarding EPSI. And some of the experience working on self-sovereign identity helped to inspire the approach in the project I'm going to present. So, as we are a University of Applied Sciences, we often need money to work. So we work usually on the research projects, and we have Flemish research projects, but we also work on European ones. And the use case I'm going to present is part of one of these European ones. It's an Interreg project from France, Wallonie, and Flanders. So Interreg, there's a lot of different ones of them in Europe, and they are always regional corporations. And within this Interreg, there's one named SecuWeb, and they're looking at the next generation of internet. So it's a very broad project. There's six technologies within. They all pass the hype curve. And our challenge, or our focus, is within the food, e-health, industry 4.0, and mobility domain, with all these partners you can see at the bottom, to come up with relevant use cases and to prototype and work towards adoption within companies. This is all background, just to present you how we're working on this. And so together with the Flemish partner series that is working on industry research, we have a specific use case which I submitted here, which I think brings relevant insights in how authentication can be approached within industrial contexts. So I'm going to present you with, I think, a quite common industrial challenge. So on Acme's floor, there's a robotic arm from a company, Robotics Inc. And access is tightly controlled within the industrial environment, and there's security zones, so best practices are in place. So if we very high level schematize this, there's an internal network, there's an application. That application has some kind of authentication. Then once authenticated, there's a different system sending over MQTT to another internal network commands to this robot. This is how it's implemented in this research facility. And this works well when you only have internal employees. But once you get to the use case where there's external ones, such as an external technician, it might start to break down. So we also assume here that Zero Trust is being implemented. Zero Trust is a framework where you never trust and always verify. So you want to avoid that if someone breaks into any system, that they can just go along then. And this is because lots of IT systems get more and more complicated, so it's really hard to otherwise to avoid disasters. So what we do in our team, we work with OpenZiti, and we set up a Ziti controller where this application communicates to the command sender through a Ziti edge router. And this is configured so that only this system can pass a command towards there. So this can be much more sophisticated. There can be, from one Ziti controller, there can be on different systems many edge routers, there can be many policies defined. However, to keep it simple here, to keep the focus on this combination, this is the most minimal approach. And still there's, within their own network, there's the authentication. But now what I want to present is, what if you have an external technician coming in? So let's say you have perfectly configured your industrial systems. So there's zero trust. It's impossible, like you need to be authenticated to communicate from system to system. All of this is working really well. Then the only or the main area of weakness that remains is actually the identification, because if you're an employee, then you are in the system. But what if you are external? What if you approach this factory and come with some kind of paper or false attestation? And this might seem a bit far-fetched, but our cybersecurity team often does pen testing or does these ethical hackings. So what happens if they go to a hospital? Sometimes suddenly they're in the middle of the server room because they do the social engineering. Often humans are the most fragile part. So it's very possible, even though you configured everything well, if you issue or you show false credentials, that you are added to this internal system, and there's actually no way to know if it's right or not, or it's hard to verify. So how could this be avoided? Let's say in this case, you have, this company has their registered technicians. What could be done is at the bottom, so you separate, you have the internal networks outside, you have the demilitarized zone, and that for the authentication, for internal employees, you communicate with your internal system. For the external ones, that you have some kind of way of communicating to the manufacturer's network. Then this could be very troublesome, because the more different suppliers you have, the more different systems you need to communicate with. Also, you start to become dependent on the security of the systems also of your manufacturer. If they have a breach or a weakness, then your security will go down. And also, if their systems are down, this could also create issues. So because our research team's background or focus is mainly on Web3, we explore different integration. And this is the part where I feel much more comfortable talking about than about cybersecurity. So this is a concept of self-sovereign identity. Just to know, how many of you are familiar with SSI, self-sovereign identity? Nobody? Good. Then I will not bother you. So on the left, this is the traditional system that we are often authenticating with. This is the way that, like when you log in, single sign-on with Facebook or with Google, so you have an identity at Google, you have one at Facebook, you might have an internal system on one website. Identities are spread all around, and it's often a hassle to maintain all your passwords or to keep your two-factor authentication, etc. in order. What self-sovereign identity aims to achieve is that actually you hold your identity and you present it to these systems. But you, and then this has a big potential if you have many different manufacturers and you want to verify their credentials, that you don't need to implement integrations with all of them. If you have more general framework, then this can be adopted instead. And that's what I will put the focus on. So some key concepts to explain self-sovereign identity well is there's a typical triangle you will see presented in these introductions. That's the idea of issuer, holder, verifier. So if a technician comes with a document signed that they are a certified technician to work on this piece of equipment, then the issuer would be this manufacturer that issues this document. The holder would be the technician holding this document. The verifier would be the employee of the industrial company that needs to check, should I grant you access to our system? Here, on the traditional way, if these concepts or these techniques here in between are not applied, then the only way to be really sure is actually to call the company. That's the most safe way to know, is this technician certified, is to call the company and ask it. However, this is very slow. So there's always a line here necessary towards the issuer to be really sure. And within self-sovereign identity, this line is broken, and this is not necessary, and this is done with cryptography combined with a well-researched framework. So the issuers, to be able to do this cryptography, they need a decentralized identity. This decentralized identity then holds their private key. They hold their, the decentralized identity, holds the public key. They have their private key. This can later on then be used for the cryptography. Then the way they present or they pass on this credential to this technician is they will not be giving a paper document, they will not be sending a PDF or sending an email, they will issue a verifiable credential. Then the holder holds this verifiable credential, and when the holder wants to present this to the verifier, this holder will make a verifiable presentation. And then through a verifiable data registry, there's a lot that can be implemented to automatically verify if this is correct or not. So for, as this is an open source summit, I assume there's a lot of technical people among you. So what does this look like? I believe this is JSON LD, linked data. On the left, you see a verifiable credential. So what is here inside? You see the schema of the verifiable credential. Then you see the DID of the issuer, the DID of the subject, so the technician, and there are claims inside, and these claims can be composed as wanted. Here it says name and contact number, but it could also be the expiry date for the credential that they are a certified technician. There could be mentioned which type of machines they are granted to work on, etc. And then very important at the bottom, and this is something that's not available with paper documents or with PDFs, also it's quite hard, is the signature. So you can see here the signature of this issuer, and this is based on the hash of the content of these claims. So if anything would be changed later on to this data, then also this signature would no longer be true. Then the verifiable presentation, it's the same. However, the part, sorry, I switched them up. Please, this is at the right side. This is the credentials. So you see the claims, this is the proof. On the left, I should swap them. I'm sorry for this. Here you see this proof. This one is here. And then the presentation. This presentation comes from the presentation. So to recap, the issuer issues a verifiable credential to the holder. This is holding claims, and this is signed by the private key of this issuer. The holder has this piece of data, and typically the word they use, the holder is holding this in their wallet. Their wallet also has access to their private key. Because their identity is mentioned in the verifiable credential, there's a link to the public key of the holder. So only the holder can make a presentation and sign this credential. If anyone else in their wallet gets hold of this credential, then they also will not be able to present. So this is cryptographically a very secure way to present your documents. Then the other part is the decentralized identity. It's just a very short introduction. This is the way that a DID is made. This can be for humans, but this can also be for AI agents. This can be for systems. It's just an identifier of something. Using this, it's possible to get a DID document. And within a DID document, a lot can be specified. The public key can be specified, but for example, also services, how to contact this entity can be mentioned. And here you see the DID method. So to retrieve a DID, it can be done through DNS, through domain name. You can host your DID document, or you can use a blockchain, or you can make a DID where this is just based on your private key and no document is needed at all. And then here you see a more sophisticated diagram how it can be retrieved. Then next to this, within this self-sovereign identity framework, what is often used is trust registry. For those who attended this morning the session by EPSI, this was also an EPSI this is implemented. So next to the DIDs that can be retrieved, for example, from a blockchain network or another system, you can also register which schemas, so you can standardize these schemas that are used within the verifiable credentials, but there can also be accreditations, so this can become more and more sophisticated. But I will try not to deviate too much. Just for the completeness, I want to mention this. So back to this use case. So before here, from our demilitarized zone, if we were trying to authenticate someone external, we made an integration with the authentication system or the identity system of this external company. Here, instead, we are not going straight to that company. We are communicating with the SSI network. This is something that I don't think is being adopted yet because it's very new technology. Mainly government is, in many use cases, adopting SSI verifiable credentials. The EU DI wallet will also probably contain verifiable credentials, so this is coming, but this is, I think, one of the first explorations. How could this be applied within industry? So what would be the difference here? And I know I made these arrows way too simplistic between UI and identity store, but I don't want to overcomplicate it also. What is different is if it's someone external, they can come with their credential, and in a standardized way, it can be validated if this credential is valid, and there can be access. If it's someone internal, it can be used with the internal system, and then using whatever internal systems there are through these OpenZiti systems and these edge routers, systems can be connected. This robot, for example, has very little authentication. The research party already had this MQTT bridge, but then it's just a matter of keeping your authentication here very well, gaining an identity to pass through this router, having your policies well, and it's possible to have the zero trust, but also not to lose it through the social engineering. Then, I think some of you might be familiar with OIDC, OpenID Connect. This is an abstraction on how to authenticate. So this is built on top of OAuth, OAuth 2. OAuth 2 was actually mainly used for authorization. However, it was often kind of abused by developers to also use it for authentication. That's why OpenID Connect was made. This is used in lots of single sign-on systems. What happens here, I didn't invent this diagram, so what happens here, you see again the issuer holder verifier coming back. This is a very useful way to wrap your head around these identity systems. Here, this happens, for example, when you use single sign-on somewhere also. As a holder, you want to authenticate with the verifier, then you will be sent to the issuer. The issuer has control over your identity. You authenticate. If it goes well, then the issuer will forward you or will send a message to the verifier. It's okay, this person can be signed on. With the OIDC for VP, a similar system can be used. However, the issuer is no longer needed to authenticate. So that's the main clue here. But the same, there's also a protocol. So the presentation is made by the holder, and then your system, when they are authenticated, then you will have the tokens that contain all the claims that the holder wants to share. So again, this is a full diagram. And this is a bit in more detail what me and my colleagues are building right now. So we have these internal networks, the demilitarized zone, this broker in between, the Ziti controller, which is a bit overkill for this small system. However, we need to anticipate that this would be in a bigger system. Some summary. So the security benefits of this layer approach is one, using the zero trust, you expect identity verification for all users. And this can happen on industrial sites that there's just no authentication, that they already assume that by having access to this building, you would have passed some check. However, here you expect it always to authenticate. For external identities, you can have these external systems, and you can also have revocation capabilities. And then you never have implicit trust. So key takeaways, and then I'm finished. So there's challenges because you have internal users, external users. A lot of this equipment is very sophisticated. You can never have all the skills within so you need to let in external staff or external technicians. Traditional systems work well internally, but are very hard to scale towards external parties because you need to have custom integrations, and it's easier to fraud on paper, on PDFs, etc. Combining SSI will make it a lot more scalable, secure. It strengthens the security and zero trust principles, and it's not that you need to change your whole system, it's just assembling all the components creatively, smart, and then this can be done. By the way, the verifiable credentials and decentralized identity, they're all standardized within W3C, so it's not that it's super new or like it's being standardized, it's already being implemented. So I think for your organizations or for your tools, it might be relevant to, or for your products, it might be relevant to look at these and to see if they are currently, or maybe if they're more adopted, if they could make your products stronger or your security better. I hope this was somehow interesting, not too much or too fast or too slow, but thank you. Are there questions?
Yes. If I want like a website and want identification of members, where should I start?
So if you want to implement this for your website?
Yes.
Yeah, then it's OIDC for VP. So where you traditionally, you would use OIDC to implement things, the way to start looking is OIDC for verifiable presentations.
Should I implement this storage? Or does it exist, storages, these verifiable, trustworthy sources that I can ask users to put their credentials on?
Yeah. Wait, first, I remember I need to repeat the questions. So your previous question was, can you implement it?
Yes, it's the same question, really.
Yeah, how to start looking to implement this on your website. So OIDC for verifiable presentations. Then where should they store these credentials? I think that's your second question. There you need to look towards wallets. And there's several kinds of wallets. There's custodial wallets and non-custodial. The differences in custodial solutions, there it will be hosted by some company, so you have some more trust you put within the offer of the wallet. The advantage is that if you change device, that you can use the same credentials, or you can have keep it on your own device, self-custodial. But there's a lot of suppliers, so the way to look for this is to look to SSI wallets. And then, because it's standardized, they should be interoperable. Yes?
I've seen that you have here two different methods of authentication. Why don't you just keep the issuer one?
So,
Instead of internal, they have for internal employees as well the issuer.
yeah. So why not have just one way for authenticating instead of creating two, internal and external? This is just to approach this pragmatically for a company with existing infrastructure, because of course they can all use these verifiable credentials with verifiable presentations, but this might be hard to implement because they're already using these internal systems. But it can be done with one. Yeah, that's true. More questions? Okay, then I'm 10 minutes ahead of time, but
Just a short one. Everything is open source we see here, even the routers.
yes, all of this is open source. For example, one open source implementation for a wallet and a lot of these components that we sometimes use at our university is Vault ID. That's also all open source, but there's many providers within LFDT There's also projects regarding SSI. I think there's the Open Wallet project. There's a lot going on, and a big trigger for that is the European Union digital identity, because every nation will have to provide their citizens with a wallet, and here these verifiable credentials will also arise. Because for these systems, that's why it's being used in EPSI, they're also very useful for cross-border verification. Let's say for a degree, if someone wants to study abroad, then the current way to assess this degree is also quite cumbersome. You have a paper with a stamp, you can scan it, or you can show the document, or they can ask the university. So how, if someone goes on Erasmus, for example, studying abroad, how do they check that indeed this person has this degree? And then these credential schemas, and this is one of the first being implemented. There was a European project, Digital Credentials for Europe. And the first thing they look towards is standardizing these, your degrees and also your grades, etc. And then cross-border, it becomes much faster, because in this trust registry, the Department of Education of your country can make an attestation or accreditation that, for example, Howest is a university. Then Howest, also their DID is registered within this framework. So when they sign the degree, this verifiable credential, it can all be verified without having to contact Howest, which is also better for privacy. And also a big advantage with verifiable credentials is depending on the scheme you use or technology, it might be possible to do selective disclosure. So currently, your ID card, if you have to present it, it contains a lot of information, your birth date, a city of birth, name. Maybe you only want to share your age, but not certain other things. Also in bigger credentials becomes even more useful. This is possible with these presentations. Then you can pick out the relevant parts. And then another thing that personally I'm very excited about is zero-knowledge proofs are also possible on these credentials. Let's say you need to prove that your income is above or below a certain amount. With a zero-knowledge proof, you can say yes, but they don't know how much. And that is all possible with these credentials that will be more and more integrated thanks to cryptography. And the main thing we need, or the main reason this goes slow, is because these are decentralized systems. So to work well, you need to have issuers and verifiers. If this stays all in the same company, that's also a bit the reason why we have this, or I designed this with two different systems. Within one company, it's a bit overcomplicating stuff. It really comes to its benefit when it needs to be verified by a different party. And a lot of current stakeholders have less incentives, because when you start decentralizing it, you give up a bit power. So that's why there's a lot of organizations that like to be the identity provider. And it's a matter, I think the technical parts are well developed. It's mainly regarding incentives and adoption, or to come towards the adoption. Yeah. Yes?
I have one question regarding the outlook of SSI networks. Do you think there will be like one big SSI network, for example, for all European manufacturers? Do you think there will be like a lot of networks where every industry or something like that will be responsible for setting up their own infrastructure?
Yeah, it's a good question, thank you. So to repeat the question, will there be one big SSI network or towards one, or will there be many different ones? The reason why I think it's such a good question is because I asked the same one recently. If I go back to the whole start, sorry. For those who want to dive deeper into self-sovereign identity, we had an expert speaker during one of our meetups, this one, Next Generation Privacy for Enterprise DLT. And the speaker here that talked about self-sovereign identity is Renata Tokhtar, and she works for DSR Corporation. For a long time, she's working on this. And I asked her the same question, and she said there will be many different ones. That's her opinion, because there can be some based on public permissionless blockchains, such as Ethereum, but then to do things there, you need to have gas. However, it's very decentralized. There might be industry consortiums that use different types of consensus or have different players. For example, EPSI. EPSI is by the European Union. Every member state has one, but they might be less flexible to adopt certain things. Another one that's growing fast is Checked, CHEQD. One that recently stopped, I think, was Sovereign, because I think Sovereign was a bit too early. However, they were one of the big enablers in this space. So I think there will be a lot of different ones, yeah. Okay, thank you. Then I think we can wrap it up. Thank you.